Hello, welcome friends. Me Anila. The topic of my discussion is about buffer part 2. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to solve toughest numericals on buffer part 2. This is part 2 of the lecture. Before coming to buffer, I want to give you a brief introduction about acid and bases. Acid is a substance that produces hydrogen ion in aqueous solution. Base is a substance that accepts a hydrogen ion in aqueous solution. Strong acids dissociate partially in strong acid dissociate completely in aqueous solution like sulfuric acid, and weak acid dissociate partially in aqueous solution like acetic acid and formic acid, etc. Strong base dissociate completely in aqueous solution such as sodium hydroxide. Weak base dissociate partially in aqueous solution like ammonia. Now, what is conjugate acid and what is conjugate base? If we have acetic acid in aqueous solution, it converts into acetate plus hydrogen ion. This acetate is conjugate base of acetic acid. Similarly, in aqueous solution, ammonia dissociates into ammonium ion and hydroxyl ion. Ammonium ion is the conjugate acid of ammonia. Now, what is pH? If pH scale is from 0 to 14, if pH is 7, it is neutral like water. If pH is less than 7, it is acidic like sulfuric acid. If pH is greater than 7, it's sodium hydroxide like strong base. Now, what is buffer? Buffer is actually the mixture of weak acid and its conjugate base, or weak base and its conjugate acid. Two types of buffer are there. Now, if there are a buffer system of acetic acid and sodium acetate, actually what does buffer do? It resists large changes in pH. For example, if we add strong acid in the buffer solution of acetic acid and sodium acetate, so strong acid causes the pH changes largely. But in buffer solution, when we add strong acid, it reacts with acetate to form acetic acid, a weak acid. So pH changes slightly. On the other hand, in the buffer system of acetic acid and sodium acetate, if we add strong base, we are changing the pH largely. Then hydroxyl ion reacts with acetic acid to form acetate, which is a weak base. So the pH changes slightly. So this is known as buffer. In this video, I will tell you how to solve toughest numericals on buffer part 2. Example. A buffer contains 0.8 molar formic acid and zero point 0.4 molar sodium formate. pKa is 3.75. Find the pH after adding 0.1 mole sodium hydroxide to 1 liter buffer. So here we have a buffer system of formic acid and sodium formate. Concentrations in molar are given. Ka is the dissociation constant of acid. Kb is the dissociation constant of base. pKa is the negative logarithm of dissociation constant of acid. So pKa of formic acid is 3.75. We have to find the pH of solution after adding 0.1 mole NaOH, a strong base. So by adding this strong base, pH must change sharply, but this is a buffer system, so pH changes slightly. So the concentration of sodium hydroxide is 1 molar because 0.1 mole to 1 liter buffer. Now we have to find the pH after adding strong base. Solution. First we will write equation HCOOH. It is formic acid reacts with sodium hydroxide to form sodium formate plus water. Formic acid is a weak acid and sodium formate is the conjugate base of that acid. Now first we have to find initial concentration already given in the example, 0.8 molar formic acid and zero point 0.4 molar sodium formate. Now when we add 0.1 mole NaOH to 1 liter buffer, concentration of NaOH is 1 molar, 0.1 molar. So the final concentration is 0.8 because 0.1 molar NaOH reacts with 0.1 molar formic acid to form 0.1 molar product. So the formic acid is 0.8 molar minus 0.1 molar is equal to 0.7 molar. On the other hand, sodium formate is 0.4 molar plus 0.1 molar. It becomes 0.5 molar. So the final concentration of formic acid and sodium formate we have calculated. Now we will apply Henderson-Hasselbalch equation to find the pH of solution. Using Henderson-Hasselbalch equation. This equation has two types. One is pH is equal to pKa plus log salt upon acid. Other is pOH is equal to pKb plus log salt upon base concentrations. So here we have pKa is already given, salt and acid are given. We have to find pH of solution. pH is equal to, we will write the value of pKa, that is 3.75 plus log salt is sodium formate divided by acid is formic acid. Now pH is equal to 3.7 plus log, we will write concentration of sodium formate which I have calculated earlier, 0.5 divided by 0.7. When we divide 0.5 by 0.7 it becomes 0.714. pH is equal to 3.75 plus log 0.714. After taking log of 0.714 by calculator, pH is equal to 3.75 plus negative 0.146. When we subtract 0.146 from 3.75, it becomes 3.6. So pH is calculated to be 3.6. We are adding a strong base to the buffer solution, but pH changes slightly. In this way, buffer is made. In this way, buffer maintains its pH. Friends, if you have any question, you can ask me on comments. I can help you. Thanks. The other part of the video, the third part, will be made by me after some time. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.